Section 6.8, Graphing Radical Functions. By the end of today's lesson, students are going to be able to graph square and cube root functions. Let's start by looking at square root functions. The general form for a square root function is y equals a times the square root of x minus h plus k. From a long time ago, if a is greater than 1, it's going to make it a vertical stretch. If a is greater than 0 but less than 1, it's going to make it a vertical compression. And if a is negative, it's going to reflect over your x-axis. Okay, talking about h. If it's minus h, remember we always think of it as the opposite. It's going to move to the right. And if it's plus h, it's going to move to the left. It would help if I could spell the word right. Okay, at the end, the plus k is going to move it up. The minus k is going to move it down. Now let's talk about the domain and the range for your square root functions. So your domain, since it's x values, you write x is greater than or equal to h. Your range, since it's y values, you write y is greater than or equal to k. The only time that's going to change is if a is negative, then the range becomes y is less than or equal to k. The parent function of the square root graph is just y equals the square root of x. So we're going to make a t-chart to find out what it looks like, and I'm just going to pick some negative numbers and some positive numbers to plug into the equation for x. So if we try to take the square root of -1, your calculator should tell you an error, so that means that this is undefined. Okay, plug in the square root of 0. The square root of 0 is 0. Plug in the square root of 1 and you get 1. And then the square root of 4 and you get 2. So you are going to only graph the points 0, 0, 1, 1, 4, 2. And your graph kind of looks like this. Here's 0, 0, 1, 1, and then 4, 2. And your graph looks like this for square roots. We are then going to take those 3 points and shift them around. Now let's add the domain. So since there is no number under this radical behind the x, your domain is x is greater than or equal to 0. For the range, check out what a is, so the number out in front, a is a positive 1. Since there's no number at the end, your range is going to be y is greater than or equal to 0. Now let's practice graphing it with the translation. So we have y equals 3 times the square root of x plus 2 minus 4. Okay, so 3 is your vertical stretch. The plus 2 is going to move your graph to the left 2. And the minus 4 is going to move your graph down 4. So vertical stretches, remember, take your y values and you multiply it by that. So 0, 0, 1, 1, 4, 2. So I take my y values and I multiply them by 3. So I get still 0, 0, 1, 3, and then 4, 6. So I'm going to start by graphing those points. So I graph 0, 0, 1, 3, and then 4, 6. So my graph looks like this. Now I need to move the points to the left 2 and then move them down 4. Left 1, 2, down 1, 2, 3, 4. Left 2, down 1, 2, 3, 4. And your final graph. Now let's talk about the domain. So you look at the h value that's under the radical. Since it's plus 2, remember it's always the opposite, so x is greater than or equal to negative 2. This should match. This farthest left value should be negative 2, and it is. Now let's talk about the range. Check what a is. A is positive 3, so that means it's going to be y is greater than or equal to. Then we need to look at the number at the end, and the number at the end is minus 4. Let's look at our graph. That should match. The lowest point on our graph should be negative 4, and it is. Now we're going to look at the cube root function. So the general form for the cube root is y equals, a times the cube root of x minus h, and then plus k. So the exact same thing as the square root, the only difference is that 2 on the outside. So the a is still a vertical stretch or a vertical compression or reflect. The h is either going to move it to the left or to the right. And the k is either going to move it up or it's going to move it down. Exact same thing as before. So let's look at what the parent function looks like. The parent function is y equals the cube root of x. So if you think about cube roots, you can plug in negative and positive numbers. And I'm just going to pick numbers that are perfect cubes. So negative 8 is a perfect cube, negative 1 is, 0 is, 1 is, and then 8 is again. So the cube root of negative 8 gives me negative 2. The cube root of negative 1 is negative 1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. And I'm going to draw you what this looks like. Alright, negative 8, negative 2 is over here. Negative 1, negative 1, 0, 0, 1, 1, 8, 2. And your graph looks like this. The domain and range for this graph is really easy. If you look at it, I know there's an h and a k, but that doesn't matter at this time. Since there are arrows on both ends, those 2 arrows are never going to stop your graph from growing in the x-axis, and it's never going to stop your graph from growing in the y-axis. So your range and domain is all real numbers. Our next example is y equals negative 2 times the cube root of x minus 1 plus 3. So that negative 2 is a vertical stretch, and it's going to make it reflect over your x-axis. The minus 1 is going to move your graph to the right 1, and the plus 3 at the end is going to move your graph up 3. So since I have a vertical stretch, I need to make my table of values. So start with your negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, and lastly 8, 2. And I need to multiply them by what a is. So in this scenario, you're going to multiply by negative 2. Let me see if I can fit this in here. So negative 2 times negative 2 gives me positive 4. Negative 1 times negative 2 gives me positive 2. 0 times 0 is 0. I'm just going to come over here, guys. 1 times negative 2 is negative 2. And then 2 times negative 2 gives me negative 4. So I'm going to go and plot those points now. So all what I did is graph these points down here. Negative 8, 4, negative 1, 2, 0, 0, 1, negative 2, 8, negative 4. Now we have to move those points to the right 1, and then we have to move them up 3. So to the right 1, and then up 3. Right 1, up 1, 2, 3. Right 1, up 1, 2, 3. Right 1, up 1, 2, 3. And then I think I need to add some more at the top. 3. So then you go to the right 1, and you go up 1, 2, 3. And so your final graph is this pink one over here. Now we're going to add the domain and the range. Since this is a cube root function, you don't even have to think. The domain is all real numbers and the range is all real numbers because the arrows are never going to stop it from growing up and out. Now let's look at rewriting a radical function. So if you notice, underneath my radical, I have an 8 in front of my x. We have to get that 8 out of there because we need to make it the a that's out in front. So we factor out an 8, and that's going to leave us with x plus 4. Then we're going to take the cube root of 8, which is going to give me 2. It's now not under my radical, but I cannot take the cube root of x plus 4, so it's going to stay x plus 4. So now I have a vertical stretch by a factor of 2, and then I'm going to move it to the left 4.